In Note 6.6, we're going to learn about inverse trigonometric functions. Previously in the year, we studied inverse functions, so I'm going to review a few of those ideas now. Graphically, a function and its inverse are reflections of each other in the line y equals x. And remember, an inverse function undoes another function. We also learned that for an inverse of a function to be a function, the original function must be 1-to-1, which means that each output is matched back to exactly one input. And the way we could check if a function was 1-to-1 graphically was to use the horizontal line test. Remember, we used the vertical line test to see if a graph is a function, and the horizontal line test to show if the inverse of a function will be a function. The domain of an inverse function is the same as the range of the original function. Likewise, the range of the inverse function is the domain of the original function. Okay, now we're going to do a little warm-up where we are going to evaluate some trig functions, actually values for sine. So to do that, we are going to think back about our unit circle. So in problem number 1, we want to find sine of pi over 6. So I'm going to sketch a unit circle. I'm going to put a point on my unit circle. This is at the angle pi over 6, and the ordered pair of that point on the unit circle is rad 3 over 2 comma 1/2, and sine corresponds with the y value of this point on the unit circle. So sine of pi over 6 is 1/2. For number 2, we're going to do the same process. So we're going to find sine of 5 pi over 6. So I'm going to draw my unit circle. I'm going to put a point at 5 pi over 6 at that angle. The coordinate on my unit circle there is negative rad 3 over 2 1/2. The sine value is the y coordinate. So the y coordinate is 1/2. So sine of 5 pi over 6 is 1/2. Next thing we're going to do is find this sine of 13 pi over 6. That's problem number 3. Well, 13 pi over 6 isn't on our unit circle, so we can find a coterminal angle. So the coterminal angle I can find by subtracting 2 pi, or I would write that as 12 pi over 6. So 13 pi over 6 minus 12 pi over 6 is pi over 6. So sine of 13 pi over 6 is the same as sine pi over 6, and we just found that value. That value is going to be 1/2. It's the same point on the unit circle, right? Because 13 pi over 6, if I want to draw it out, would be a full revolution plus pi over 6. What about 17 pi over 6? That's problem number 4. 17 pi over 6 isn't directly on my unit circle, but once again, we can think about a coterminal angle, and I could subtract a full rotation from 17 pi over 6. So I would subtract 12 pi over 6, which is 2 pi, which would give us 5 pi over 6, which is the same value we just found in number 2. So 17 pi over 6, the sine of 17 pi over 6 is simply 1/2, because we are at the same coordinate on the unit circle, which would be here, because we would rotate around full rotation and then another 5 pi over 6. What about negative 11 pi over 6? This is what we need to find in number 5, sine of negative 11 pi over 6. So negative 11 pi over 6 isn't directly on our unit circle, but we can find a coterminal angle once again. So to find a coterminal angle, we add a full rotation, 2 pi, which I will write as 12 pi over 6. So negative 11 pi over 6 plus 12 pi over 6 is pi over 6. So sine of negative 11 pi over 6 is the same thing as sine of pi over 6, which is the same point on my unit circle, so that's going to be 1/2. And now we have sine negative 7 pi over 6. Negative 7 pi over 6, I could draw this angle out on my unit circle if I wanted to. It's not directly on the unit circle, but it is if I rotate in the negative direction. So if I rotate in the negative direction, this angle is negative 7 pi over 6. It leads me to the same point on the unit circle as I had in numbers 2 and number 4. So sine of negative 7 pi over 6 is 1/2. You could also do this as a coterminal angle where you could add a full rotation. So you could have negative 7 pi over 6 plus 12 pi over 6, which would be 5 pi over 6, which is the same thing as number 2. So what happened here? What is sine inverse of 1/2, right? So if the output is 1/2, what angle gave that input? What angle was the input? So, is it pi over 6? The answer to number 1? Is it 5 pi over 6? What we got in number 2? Is it 13 pi over 6? Or 17 pi over 6? Or negative 11 pi over 6? Well, actually, maybe I'll write that out the other side. Is it negative 11 pi over 6? I'll put that here. Or negative 7 pi over 6. Or we could go on forever, right? So which should we pick? And that's a question. What is sine inverse of 1/2? So for sine inverse, for this new function that we're going to talk about, for it to be a function, each input must have exactly one output. That's a definition of a function. So how could sine inverse of 1/2 be all of these values? It can't, right? So in order to make sine inverse a function, what we're going to do is we restrict the domain of f of x. I won't call it f of x. I'll just call it y equals sine x. So it will have an inverse that is a function. And that's what we're going to be doing in the next examples.